Okay, numeric response number 8. The absolute maximum value of the function, and you can see it right there, to the nearest hundredth is. Okay, to the nearest hundredth suggests to me I should get my calculator ready. Now, the absolute maximum, that's an interesting thing to ask for, that absolute. Now, at this point I don't quite know what to make of that, so we're just going to jump in and look for our locals first. So, what we're going to do is take the first derivative. Now, 2x over x squared plus 16, I'm going to have to use the, well, I don't have to, but I'm going to use the quotient rule here. So 2 times x squared plus 16 minus 2x, that's the numerator, and the derivative of the denominator will also be 2x, all over x squared plus 16 all squared. Okay. Now I'm just going to expand that all out and get 2x squared plus 32 minus 4x squared all over x squared plus 16 all squared. And so we're going to get negative 2x squared plus 32 all over x squared plus 16 squared. Okay, so now our critical numbers are going to be where the derivative here is either 0 or undefined. Now, again, before we do that, we should take a quick look up here and just think, well, wait a minute, is there any place, like what's the domain of this original function here? And the domain, and I'll write it over here so it's off to the side. 2x over x squared plus 16. Yeah, is there anything? No, I don't care what some of the geekier ones of you want to do here. We're not dealing with complex numbers, so no. The domain is going to be all reals. Okay, don't worry about where it's complex numbers. Don't do that. It's all reals. So now we just got to take a look here. Where does my numerator go to 0? Where does my denominator go to 0? Well, the denominator is not going to 0. Okay, no matter what you plug into this, because it's being squared, nothing is going to be able to cancel out with that 16. So that's not an issue here. However, if we take a look at the numerator here, that is going to go to 0 when x is either equal to positive or negative 4. Okay, so those right there become our two critical numbers. Now, what we're going to do here is I want to take a quick look at what's happening with this particular function here. Now, the easiest thing to do in this case right here, based on what I want to do with this, is to kind of sidestep this. I'm going to come back down here, and I'm going to factor this out. And when I do that, I'm going to get negative 2. This will be x plus 4, x minus 4, all over x squared plus 16 all squared. Okay, and I'm writing it out like that because I want to take a good look at this right here. This is going to break up the number line for me. I'll do it over here. Into what do we got here? 3 distinct regions here. We've got negative 4 and positive 4. And then the factors that go along with this, I have got negative 2, x plus 4, x minus 4, and then my denominator, and I'm going to put the entire denominator together because the whole thing is being squared anyway. Okay, so a couple of things to note here. Negative 2 is always going to be negative no matter what the value of x is. X squared plus 16 squared is always going to be positive no matter what the value of x is. X plus 4 is only going to be equal to 0 here. It'll be negative to the left and positive to the right. X minus 4 is going to be 0 here at 4. It'll be negative to the left, positive at the right. And then if we put all those factors together, okay, negative times a negative divided by a positive is going to be negative. Negative times 0, well, okay, as soon as you multiply by 0, think 0. Negative, positive, putting all that all together, that's positive. Negative, positive, 0. Okay, there's my 0. And then this is all negative. So now we see that this function is increasing on the interval negative 4 to 4. It is decreasing negative infinity to negative 4. And then from 4 out to infinity. Okay, so what we're seeing here is we've got, at these 2 points here, we've got these critical numbers. These could be maxes or mins. So I'm decreasing and then increasing. So that's a minimum. and then increasing, and then decreasing again. So what's got to happen here is that right there has got to be my max. And so at 4 here, so now what I'm going to do is evaluate the function at 4, and that will be x squared. So, sorry. I knew that it was 4. I don't know why I did that. So this will become here 4 squared plus 16. So this is going to become 8 over 16 plus 16 is 32. And so 8 over 32, 1/4. Now, it says absolute here. We got to think about that. What exactly is going on here? Well, okay, we've seen enough calculus now to know that this thing here has an asymptote, okay, a horizontal asymptote at 0. Okay, so in any case, actually, you know what? What might even be easier at this point here, because I don't want to make this, I don't want to make a really big deal out of this, specifically because of how this function works here. Probably the easiest thing to do at this point here is to just take a quick look at and graph it. And oh wow, I got to go through and delete a couple things here. Hold on, I am getting there. I am getting there. Okay, so I'm going to do 2x divided by bracket x squared plus 16 and my window settings aren't quite right to see that, so I'm going to go to zoom standard. And actually, yeah, what we're getting here is a graph that looks something like this. It's approaching. Yeah, it's a little hard to see. Let me see without going through the whole process here. And I just know that here that ends up being an absolute because it's approaching that horizontal asymptote of 0 on either side.